Welcome to Pharma Drama, the channel where we look at the science of healthcare and healthcare products. More precisely, we try to explain science concepts clearly and concisely. Or should that be more accurately? You're not sure, are you? Fear not. Almost every student I've known uses the words accurately and precisely interchangeably, but they are definitely not the same thing. So in this video, I'm going to explain the difference between accuracy and precision using only a box of ibuprofen tablets and some data. Oh, and a hot drink, of course, which today is coffee. Tremendous. Right then, let's make a start. If you were in the lab recording data, would you want to make sure you were working accurately or precisely? Or both? Or neither? I hope not the latter. Almost everyone I know uses the terms accuracy and precision interchangeably, but they do in fact mean very different things. And it's important to know what they mean, principally because once you understand them, you can look at data, your own or those of other people, and assess how good they are and whether they're affected by systematic or random errors. We'll look at how you do that in a bit. First though, we need to understand why we make measurements in the first place. That is, of course, because we want to understand something about a sample. In the pharmacy world, maybe how heavy tablets are, or what the drug content of a medicine is, for example. We design an experiment, perform it, and record an answer. Usually, we don't perform an experiment just once. That's because there's always an amount of uncertainty in making measurements. So we try to account for that by making measurements a number of times, and we look to see how much variability or spread there is in the data. We do this by determining the central tendency, usually the mean, and the standard deviation. If you're not sure what these terms are, fear not. I have videos on that, of course, the links for which are in the description below. And while I think of it, if you find these videos helpful, please hit the like button and consider subscribing. It really helps the channel. Thank you. But in brief, the mean is the average value of a set of data, while the standard deviation quantifies how much variability or spread there is between data points. Accuracy and precision relate to the mean and standard deviation respectively, which is why knowing these values is so important. Accuracy means how close your data are to the true or expected answer, which is shown by the mean, while precision means how large the spread is in your data, which is shown by the standard deviation. So right there, I hope you can see that accuracy and precision are not the same thing. But let me explain further with an example. Here is a box of tablets. The active ingredient is ibuprofen, and each tablet should contain 200 milligrams of drug. We know that because it says so on the box. But how does the manufacturer know how much drug each tablet contains? To determine the drug content, a tablet must be crushed and dissolved in water before some sort of assay is used to determine how much drug is present. Clearly, this analysis cannot be done for every tablet in a production batch because we'd have no tablets left at the end. Instead, a number of tablets from each batch are selected. We call that a sample, and the drug contents of these are determined. We then assume that the results from our sample match with the whole batch, which we call the population. It's kind of critical then that the assay on the sample tablets is performed to a high standard, such that we can trust the data. And we can assess whether to trust the data by determining whether they are accurate, precise, or, ideally, both. Imagine I collect samples of 5 tablets from a batch of ibuprofen tablets and give them to 4 students of varying ability to assay. Each tablet notionally contains 200 milligrams of ibuprofen, so that is our true or expected answer. Each student follows the same protocol for the assay and provides 5 drug content values. The results are shown in this table. What can we make of these results? Exactly, not much. It's very hard to see a trend in data when they are tabulated. In fact, when students present me data in a table, I'm usually quite cynical and assume they're trying to hide something. What happens when we instead plot the data? The graph shows the drug content values determined by each student. The horizontal dashed line shows the expected answer, 200 milligrams, and the small arrows show you the mean for each data set. Now it's much easier to see what is going on. And I hope you can see that each student appears to be performing very differently. Let's look at the data for each student in turn. Starting with student number 1, what can we see? All of the data values are closely bunched, which means there is little spread in the data and the standard deviation is small. And the mean is very close to the true answer. We can therefore say that student number 1's data are both accurate, because the mean is close to the true answer, and precise, because the values are bunched together. Very good. Notice how we can determine that student number 1 is operating with both accuracy and precision only by looking at their data. What about student number 2? What can we say about this student? I'll give you a moment to think about that. Got some thoughts? Well, looking at the values, we can see they are tightly bunched, which means the standard deviation will be small, so the data are precise. But look at the mean. It's not close to the true value, so the data are inaccurate. We can say student 2 is operating with precision but is inaccurate. Does it surprise you to know that data can be precise but inaccurate? It should if you use those words interchangeably before. And what do these data tell you about how student number 2 is operating in the lab? It suggests that the student is performing each assay repeatably because the values are tightly bunched. But nevertheless, the answer is wrong, most probably because of an instrument being badly calibrated or faulty. We call this a systematic error, as in the fault lies with the system, not the operator. Again, we can tell a lot about the performance of student number 2 from the data. Now that you're getting familiar with analysing data, tell me what you think is going on with student number 3. Think first about the spread in the data. Is it large or small? Exactly, it's large, so the data are imprecise. Then look at the mean. Is it close to the true answer or not? No. So the data are inaccurate. Student number 3 is operating without accuracy or precision, and we probably need to summon them for a chat. Finally, what do you think is happening with student number 4? The method of interpretation is the same. Look at the spread first, and we see the data are pretty variable. So that means they're imprecise. Now look at the mean. Actually, it's pretty close to the true value. So amazingly, the data are accurate. Student number 4 is operating with no precision, but with accuracy. This means there is no systematic error in the assay. The student is just doing things carelessly in the lab. So there's a lot of random errors in the data. But this highlights an interesting point. When data are genuinely random, the more repeat measurements are made, the more likely the mean will tend to the true answer. Does that surprise you? It's because with random errors, for every overestimate in a value, there is a corresponding underestimate, and these will cancel out, causing the mean to tend towards the true value. This is called a Fermi estimation, after Enrico Fermi, who said that the more factors there are in a calculation, the more likely it is that you can estimate the true answer by guessing a sensible value for each. This is why it's so important to make repeat measurements, and not just the 3 that all students seem to think is fine. So we might call student number 4 into the office for a chat about how they're working in the lab, but at least we know the equipment's okay. Hopefully that made sense, and you now see that accuracy and precision are certainly not the same thing. Accuracy means how close the mean of a data set is to the true value, and precision means how much spread there is in repeat data. Being able to look at data and assess their accuracy and precision means you can understand something about how the person recording them was operating in the lab, and in particular, whether there's a systematic error somewhere that needs to be corrected. I hope you found that useful. If you did, please tell your friends and colleagues about the channel. And if you have suggestions for topics, please let me know in the comments below. Otherwise, thank you so much for watching, and I'll see you again soon.